After an extremely mild December, much of the U.S. was caught off guard by the January 23rd Arctic storm. Within days, thousands of flights were grounded, millions lost power, and at least 130 people died, either from hypothermia or from unsafe heating and lighting as power systems failed. This was the deadliest winter storm since the 2021 Texas Big Freeze, which caused 246 confirmed fatalities. And yes, despite the bitter cold, we're still talking about global warming, because climate change played a role in both events. The issue isn't how cold the Arctic gets, it's how stable it is. The Arctic is warming far faster than the rest of the planet, and that weakens the air currents that normally keep cold air locked in the far north. A mild early winter slows and destabilizes those currents. At the same time, warmer air holds more moisture, increasing the odds of intense precipitation. When the system finally breaks, Arctic air can spill far south, linger longer than usual, and fuel severe snow, sleet, and ice. So climate change doesn't eliminate winter. It replaces predictable winters with sudden extreme cold shocks, sharper, harder, and far more disruptive. That's the quick version. But to understand why January's storms hit so hard, we need to look at a process called Arctic Amplification. In simple terms, while the planet as a whole is warming, the Arctic has been warming about 4 times faster than the global average. And it's not just temperature that matters, it's the difference in temperature between regions. That contrast is what drives atmospheric stability. And as it weakens, weather becomes increasingly erratic. I'm going to break this down in 4 chapters. Chapter 1, the melting mirror. The technical term is the Albedo Effect, but the idea is simple. Light surfaces reflect heat. Dark surfaces absorb it. That's why people wear light-colored clothes in summer and darker ones in winter. It's not just fashion, it's physics. Since the 1980s, the Arctic has lost roughly 75% of its sea ice. As bright white ice disappears, darker ocean water absorbs more heat instead of reflecting it. That added warmth accelerates further melting. The hotter it gets, the hotter it gets. Chapter 2, the Leaky fridge effect. The temperature difference between the warm tropics and the cold Arctic drives the jet stream, the fast-moving air current that circles the northern hemisphere. As that temperature difference shrinks, the jet stream slows. It begins to wobble and meander. Think of a garden hose. When the pressure is high, the stream shoots straight. Lower the pressure, and it bends, flexes, and snakes around. Those bends allow chunks of the polar vortex to break loose and slide south. It's like a spinning top losing balance and drifting across the floor. That slow, unstable wobble is what carried January's Arctic air deep into the continental U.S. and kept it there. Chapter 3, increased humidity. Much of the country enjoyed a mild December, but warmer air can hold more moisture, about 7% more water vapor, for every degree Celsius of warming. When that moisture-laden air collided with invading Arctic cold, conditions were primed for a perfect storm. Heavy snow, sleet, and freezing rain followed. NOAA reported over 700 incidents of ice accumulation and freezing rain damage below the snowline, stretching from central Texas to North Carolina. Chapter 4, the human cost. Roughly 2.5 million customers lost power, mostly in regions hit hardest by ice and freezing rain. And each customer represents a household or business, meaning several million people were left without electricity during a dangerous cold snap. Temperatures plunged to minus 40 degrees Fahrenheit in parts of the Midwest and dropped into single digits across the South. And the South faces a particular vulnerability. Much of its infrastructure was never designed for sustained extreme cold. Beyond the loss of life and power, reinsurance broker AON estimates total damages will exceed $1 billion. January's Arctic storm didn't contradict global warming. It happened because of it. My hope is that understanding these connections helps us stop being caught off guard. Because this isn't just a southern problem. Aging infrastructure is an issue nationwide. The Department of Energy reports that roughly 75% of U.S. power lines are over 25 years old, with much of the grid dating back to the 1960s and 70s. Upgrades cost money, but ignoring them often costs far more, both financially and personally. And as individuals, many of us are starting to recognize that preparedness matters too. Paying attention to weather alerts, planning for outages, and knowing how to stay safe and comfortable if the grid fails. Stick around for more climate science, disaster prep, and resource resilience, critical topics for adapting to a changing world. If you found this helpful, consider subscribing to Kat Monet's Doom Scrolls. We're not really doomers at all. We're an emerging community of survivors. Take care and don't forget to prep.